Moving on to logarithms today, or logs as you probably know them. I just want to remind you of some properties that are on your note sheet. So here's the first one, the property of equality. If you have the same base, if you have the same base and then their exponents must be the same too. So like 4 squared has to be 4 squared. 4 squared cannot be the same as 4 cubed. That would not be right. So if your base is 4, then both exponents have to be the same in order for that to be true. So that's just the property of equality. So obviously here, if the bases are both 3, in order for those two sides of the equation to be equal, then x has to be 6, because it's the only way that that is going to work. All right, so sometimes you want to solve algebraic equations and you want to be able to use this property of equality, which means you have to have the same bases on both sides of that equal sign. And so what you want to do here is you want to rewrite that 81 as a power of 3 so that you have the same base. And 81 is 3 to the 4th power. And then you have this, and of course the only way these two sides of the equations are going to be equal is if the exponents are equal. So I'm going to set the exponents equal to each other and make 2n plus 1 equal 4. And then of course I will solve, so 2n equals 3. I'm sorry, you know what? Oh yeah, 2n equals 3, and n equals 3 halves. Okay, so that's how that should go. When you're doing this, when you're dealing with logs and exponents, you should always check this. Okay, you should always check this. So you should plug it in. 2 times 3 halves up here. Of course, the 2's cancel, and then you'll have 3 plus 1's, and 3 plus 1 makes 4. And yes, 3 to the 4th does equal 81. So check these because sometimes you get extraneous solutions. Here you have two sides of the equation that both need to be changed. I cannot write 8 as a power of 4, but I can write both 4 and 8 as a power of 2. Okay, so I'm going to write 4 as 2 squared, and then of course I have this 2x out here, and then I have 8 as 2 cubed, which of course I can take to the x minus 1 power. Now I've got them both written as powers of 2, that's good. And then again, I need to use my exponent properties and realize that when I'm taking a power of a power, like I am here, I would multiply my exponents. And so this becomes 2 to the 2 times 2x, which is 2 to the 4x. And of course here I would also multiply my exponents. Be careful because this is really 2 to the 3 times the quantity, x minus 1. So make sure you multiply that 3 through the x and the negative 1, not just to the x. That's a common mistake people make. Now, of course, the only way these sides are going to be equal is if your exponents are equal. So 4x must equal 3 times x minus 1. Or, of course, 4x equals 3x minus 3. And then if I subtract 3x, I get x equals negative 3. And of course, I do always want you to plug it in and check it, because again, sometimes you get ones that won't check. So the question is, does 4 to the 2 times negative 3, which would become 4 to the negative 6, does that equal 8 to the negative 3 minus 1, or 8 to the negative 4th power? And if you check that out, it does work. Okay, so that is a true statement. Okay, then sometimes when you want to solve equations, you can't get both sides of the equation with the same base. Like here, I can't write the number 2 and the number 7 with the same base. And so you have to have another method to solve, and that is why you would want to use logarithms. Okay? So you have this exponent, right, or this logarithmic thing right here. Just so you know, neither your b or your x can be negative, so make sure that you know that. This is red, log base b of x. Neither your b or your x can be negative when you do this, okay? So here we go. And this is on your master formula sheet, just so you know. I don't know what that's all about. All right. Moving over here. If we want to be able to write these in exponential form, then we need to be able to go back and forth from one form to the other. So of course, when it's in logarithmic form, this becomes your base, this becomes your exponent, and this right here becomes what it's equal to. So this should become 8 to the 0 equals 1. Over here, again, base, exponent, what it's equal to. So I can switch back and forth from exponential form to logarithmic form, and that's what those should look like. Okay. Moving on to the next one. Now I've given it to you in exponential form, and I want you to give it to me in logarithmic form. And so we will go backwards here. And so again, you're going to go log. This is your base, so that's 10. Over here on the right side of the equation is your exponent, and this is what it is equal to. So log base 10 of 1,000 is 3. Okay? Then again, over here, log. Here's your base, is 9. Your exponent goes over here, and what it's equal to goes right there. So that's how you switch back and forth from exponential form to logarithmic form. All right, so now when I ask you to evaluate this, log base 2 of 64, one thing you can do is just put a variable on the other side of that equation. Set it equal to a variable. In this case, I set it equal to y. Okay? And when I set it equal to a variable like that, that will help me because then I can, if working with it in logarithmic form is not working for you, then switch it to exponential form. So right now, there's nothing I can do. I do have a log button on my calculator, but you will learn later on that it is only logs in base 10 that you can use your calculator for. So when I have logs in base 2, my calculator is not going to be helpful until we remember some other tricks. So for right now, just know that logs in base 10 are the only way your calculator is going to be helpful for you. So in logarithmic form, this is not helping me right now. But if I switch this to exponential form, then I will know that I have my base, my exponent, and what it's equal to is right here. And now, luckily, I can rewrite 64 as a power of 2. So I can go 2 to the y equals, and then 64 is 2 to the 5th power. 6th power. 64 is 2 to the 6th power. Okay, and then of course then I know that y has to be 6. And if you plug that in and check it, it works every time. Okay, then moving on. Okay, again, this is not helping me in logarithmic form, so I am going to set a variable here and I'm going to switch this to exponential form. And so then I will have 2 to the x equals 3. This didn't help me either because I can't get 2 and 3 both in the same bases, okay? Can't get 2 and 3 both as a power of the same number, so that is not going to help. When that happens then, what you want to do is you want to take the log of both sides. So I am going to take the log of this and the log of this. Okay, so that's what I'm going to do. If you remember your logarithmic rules, when you are taking log of something raised to a power, this power ends up going right in front. So what this really becomes then is x, that came out in front, the exponent came out in front, of log 2 equals log 3. Now do you see how you have no number written as your base of those logs? Then you can assume that it's in base 10 and your calculator will be helpful for you. Okay, so to solve for x, I want to divide both sides by log 2. And then you can put that into your calculator. So you're going to go right to your calculator. You're going to press log 3 divided by log 2. Check that out on your calculator, and x should come out to be about 1.58. Okay, make sure you know how to do that on your calculator. All right, so that should do it for this lesson.